The term information technology in English is derived from the French word informatique or informatica in Russian, encompasses the notations of information handling. Abbreviated and more popular as IT, information technology is a new science of collecting, storing, processing and transmitting information. If we pay attention, we see the word information technology is a combination of two words, namely information and technology. Information means knowledge. IT is science of information handling, particularly using computers to support the communication of knowledge in technical, economic and social fields. For some, information technology is the application of computers and other technologies to the acquisition, organization, storage, retrieval and dissemination, and for some, IT is scientific, technological and engineering disciplines and management techniques used in information handling. Technological change has become such a driving force in our society that information technology has become a generic term used for a group of technologies. James William identifies the 6 major new technologies as most relevant in modern library and information systems. These can be listed as processor, memory and input-output channels, micro, mini and large-scale computers, mass storage technologies, data communication, networking and distributed processing, data entry, display response, and lastly, software. A computer is a data processor. It can accept input, remember the input by storing it in memory cells, process the stored input by performing calculations and by making logical comparisons, and it can communicate or output information. In a simple way, a computer is a machine that carries out instructions. The set of instructions which tell a computer to execute a series of specific tasks is called a program. A computer is more accurately referred to as a computer system consisting of hardware, the physical components, and software, the program that controls it. These technology can also be grouped into 3 major areas, namely computer technology, communication technology, and reprographic, micrographic, and printing technology. The figure shown here depicts the interrelatedness of various components of computer system, as well as the construction of the latter. Input devices such as keyboard or mouse are the means by which the computer takes in symbolic data and instruction. Let us have a glance through the names of various devices used in different categories of input devices. Software is a set of instructions that direct the operations of a computer. A program is a sequence of instruction. An instruction may be an arithmetic operation or a logical operation. System software controls various internal computer activities. Any software that can control such activities will fall into one of the 3 categories, namely operating system, utility software, and programming language. The operating system is a group of system programs that help in operations of a computer by telling the computer how to interpret commands, process the inputs and outputs, and manage data. As is automatically loaded when PC is started and can activate other programs. For example, Windows 98, Windows XP, Windows Vista, and Linux. Utility software expands the performance of the operating system by adding functions that are not a part of the original OS. Utility performs such jobs as troubleshooting hardware, inspecting diskettes for damage, file conversion, defragmentation, data compression, etc. Some utility programs such as semantics, Norton utilities, even retrieve data from damaged disks. Utilities can also be used to customize the OS environment. Application software, or simply called apps, is used to perform specialized functions or specific jobs. Specific jobs might be to create a family tree, learn basic math or quantum physics, create a plot for a novel, do payroll and accounting, draw flowcharts or a dream house. Regardless of type of tasks, users can choose from thousands of apps to facilitate the job. To help sort out the thousands of apps, the software publishing industry tracks more than 35 categories. 4 of the major categories that represent the progress of application software are word processing, spreadsheet, database management, and entertainment. Let us have a look at major categories of the application software. Programming languages are the various methods of writing computer instructions. The instructions adhere to a particular set of protocols for each language. Through the years, more than 200 languages have been developed, some of which are quite popular, include BASIC, COBOL, Pascal, C, C++, Visual Basic, and Fortran. The first generation of computer languages was machine language. Machine language was very difficult to use, time-consuming, filled with errors, and limited a programmer's creativity. Programs in machine language consist of instructions coded in zeros and ones. Thus, the alphabets of machine language are zeros and ones. The second generation of computer language, assembly language, was developed in the 1950s and reduced the complexity of program authoring by using symbols instead of zeros and ones. However, each computer or family of computer had its own assembly language that prevented software of one computer model from being used on different computer models. Although programming became easier to write, it remained idiosyncratic with its lack of portability. Third generation language, 3GL, called high-level languages, were developed for two reasons. One, programmers could work on different computers without having to learn a new assembly language each time, and software written on one computer would be used on another. A compiler or program translator was used to help solve these problems by translating a program into machine language and checking the program for syntax errors. The advent of compiler greatly reduced the programmer's burden of memorizing specific codes for each machine. Examples include BASIC, C, Pascal, etc. Fourth generation languages, 4GL, called very high-level languages, use a similar language translator but require fewer lines of code because they rely on objects of code that are reusable. These predefined objects have numerous strengths such as portability, easy structuring, and simplified development, but also make the languages less flexible. Examples include Java, C++, C#, etc. In the world of computer, networking is the practice of linking two or more computer devices together for the purpose of sharing data. Networks are built with a mix of computer hardware and computer software. The dictionary defines a network as a group of computers and associated devices that are connected by communication facilities. Thus, a network can be anything from two computers connected by a serial cable to thousands of computers connected by high-speed data communication links dispersed throughout the world. The individual computers in a network are often referred to as nodes. A network provides the following major benefits, namely simultaneous or concurrent access to critical programs and data, sharing of peripheral devices, streamlined personal communications, and easier backup processes. Any network can be studied in one of the ways shown in the figure. It is important to realize that these are not mutually exclusive divisions. For example, a LAN may have any of the four topologies, and also it may have any of the three types of interactions. Let us study each of these above topics in more details. Databases have been around for a very long period, so much so that it may even be said that the moment human beings started systematically recording facts pertaining to their lives and businesses, database came into existence. Before we study database concepts, let us get a clear understanding of the various terms we shall use. Number one is data. It refers to the fact that can be recorded and be stored on computer media. Information refers to data that is viewed in some context and helps the user reveal trends or patterns in the data. While database is shared and organized collection of logically relevant data designed to meet the information needs of multiple users in an organization. Today, databases touch all aspects of our lives, and their importance stems from facts like their ability to make database management more efficient and effective and reduce the probability of inconsistent data. Database has evolved along the evolution of programming languages. Different stages of evolution can be understood by following the table given. At the lowest level of programming, database took the form of simple ideas of storage within the program. The contents of such database were hard-coded into program or otherwise created, destroyed or manipulated without reference to any database outside the context of that program. To understand the working of the database system, it is important to understand the levels of abstraction of data. This means the different ways in which we can view the data. A database system typically has three data abstraction levels, namely physical level, logical level, and view level. Physical level describes how a record is physically stored on the computer. Logical level describes data stored in the database and relationships among them. Under view level, data is seen by the end user. Application programs hide details of data types. View can also hide information if and when needed for security purpose. Data modeling is the analysis of data objects that are used in a business or other context and the identification of relationships among these data objects. A data model is a collection of logical constructs used to represent the data structure and data relationships found within the database. The two different categories of data models are conceptual model and implementation models. Conceptual models focus on logical nature of data representation and are concerned with what is represented rather than how it is represented. Implementation model places the emphasis on how the data are represented in the database or on how the data structures are implemented. The examples include hierarchical model, network model, relational model, object-oriented model, and semi-structured model. IBM released its first commercially available DBMS, IMS, based on the hierarchical data model. The basic structure of this model was released in 1966. Includes collection of records is logically organized to conform to the upside-down tree structure. The top layer is perceived as the parent of segment directly beneath it. The segment below other segments are the children of the segments above them. And a tree structure is represented as a hierarchical path on the computer's storage media. General Electric or GE developed a DBMS called IDS or Integrated Data System based on the network data model in 1967. In this model, a relationship is called a set. Each set is composed of at least two record types, an owner record and a member record. A set represents a 1:m relationship between the owner and the member. The following is a visual representation of a network DBMS. The figure shows the network DBMS. Despite its major advantages like conceptual simplicity, data access flexibility, conformance to standards, etc., the model was discarded owing to its disadvantages of system complexity and lack of structural independence. We've already seen that DBMS is a collection of programs that manages the database structure and controls access to data stored in the database. The various functions performed by this software for achieving these goals are data dictionary management, data storage management, data transformation and presentation, security management, multi-user access control, backup and recovery management, data integrity management, database access languages, and application programming interfaces and database communication interfaces. The figure shown here depicts how the DBMS sits between the database and the end user.